let's destroy a massive myth right now, literally in the first 10 seconds of this explainer. Simply knowing the physics equations, it is not enough to pass the Cambridge AS and A-Level 9702 exam. Seriously, if you think just memorizing a bunch of formulas is going to magically get you an A, you are walking straight into a trap. Today, we're breaking down the exact strategy to completely conquer physical quantities and estimates, which, by the way, appears in absolutely every single examination series. Okay, let's dive right into this. So the principal examiner report reveals a really painful truth. It says, even if your final answer is wrong, method marks can save you. Look, candidates are losing massive grade boundaries, and it's not because of a lack of physics knowledge. It's because they hide their working. The examiners are basically begging you to show your process. If your final calculation goes slightly off track but your method is totally sound, these method marks are your safety net. By not writing down your structured thoughts, you are literally leaving free marks on the table. So the absolute crucial point here is this. Are you losing marks because you don't know the physics or because you just don't know the examiner's mindset? I really want you to treat this explainer as a completely legal heist on the Cambridge mark scheme. We aren't just going to sit here and learn the concepts. We're going to learn exactly how to extract every single available mark from that exam paper, and it's going to transform how you tackle these questions from today onward.
Here is our three-step heist plan. Step 1 is the core quantities speed run. Step 2 is the method mark strategy. And step 3 is the before and after shock.
All right, step 1, the core quantities speed run. Let's get back to basics for a second. A physical quantity requires both a specific magnitude and an appropriate unit. A number without a unit is completely worthless on the mark scheme. I mean, think about it. If you calculate the length of a wire as 2.5, the examiner is just sitting there wondering, 2.5 what? Meters? Miles? Elephants? Precision is absolutely everything here. And this applies heavily to estimation questions too. Knowing the everyday order of magnitude, like, the mass of a car being about 1,000 kilograms or the rough wavelength of visible light, is totally essential for grounding your math in physical reality. We actually have hard data from past principal examiner reports that highlights the top 3 fatal mistakes students make year after year. First off, answers are just way too vague. Examiners demand specific technical details. Second, students completely ignore format and presentation conventions, like they just don't care. And third, answers are often rote memorized and not applied to the specific context of the question. Listen, if you apply a generic textbook answer to an unfamiliar context on the exam, you will be penalized, for sure.
Moving on to step 2, the method mark strategy.
Now, in just a moment, I am going to show you the exact examiner clue that changes a total 0-mark calculation into a full-mark, top-band answer. But first, you absolutely need the framework that makes that clue super obvious. Without this framework, honestly, you'll look right past the hints hidden in the exam paper. So here is your primary weapon for literally any estimation or calculation question. It's the deconstruct, solve, evaluate protocol. Let's break it down. First, you deconstruct the question. You identify the given information and break the whole problem into logical, bite-sized steps. Second, you solve it systematically using clear notation. Please do not skip steps in your head. The examiner can't read your mind. Finally, you evaluate. Check your final estimate for reasonableness. Like, does a 2mm wire really have the volume of an Olympic swimming pool? Probably not, right? If your answer looks insane, you definitely need to go back and check your unit conversions. Let's see how this actually builds into our written responses. When you construct your answer, map it out using this exact 4-part flow: concept, evidence, scientific reasoning, and examiner wording. It's like a formula for writing. Start by stating the core physical concept. Then pull the specific evidence or data straight from the tables they provide you. Connect those pieces using logical scientific reasoning and wrap the whole thing up using the exact correct terminology expected by the examiner. This sequence aligns perfectly with their assessment objectives. And that brings us to step 3, the before and after shock. Consider this incredibly common exam scenario. We have a wire with a length of 2.0 meters and a diameter of 0.5 millimeters. Your goal is simply to estimate the volume of this wire. It seems super straightforward, doesn't it? But trust me, this exact setup destroys grade boundaries every single year.
So I want you to actually pause and predict right now. Mentally construct your answer. How exactly would you present this calculation on the paper to guarantee you get every single method mark, even if your thumb slips on the calculator and you make a math error at the very end? Think about the units. Think about the formula you'd write down. Have you got a picture of it in your head? Okay, let's reveal the trap.
Here is the devastating before and after shock. A zero-mark attempt features a student just frantically punching numbers into a calculator, mixing up millimeters and meters, and then scribbling down a raw number with absolutely no formula and no units. Contrast that with a flawless top-band answer. The formula for the volume of a cylinder is explicitly stated right at the top. The diameter is clearly converted to meters, the step-by-step logic is completely visible, and the final answer has a very clear unit of cubic meters. This right here is exactly how you steal the marks. So, resolving what we talked about earlier, here is the exact examiner clue that changes everything. The syllabus itself specifically states that marks are awarded for proper headings, correct terminology, appropriate formats, and clear annotation. Presentation isn't just about making your paper look pretty, it is a fundamental procedural framework that you are being directly assessed on. Step 4. Evaluating the evidence. Top-performing students always use this critical analysis checklist. When you make an estimate, you must state your assumptions. For instance, in our last example, did you assume the wire's diameter was perfectly uniform the whole way down? What are the actual practical limitations of measuring a 0.5 millimeter diameter in a lab? You need to analyze how these uncertainties affect your final conclusion. Highlighting these limitations shows the examiner that you don't just know the math, you have a deeply connected conceptual understanding of physics in the real world. And you can literally see the payoff for this strategy right here. It's a massive shift in your grade boundaries. Just throwing down the final answer earns you very, very low marks, but you see a huge jump in credit simply by showing your working, instantly securing those method marks. But combining structured working, correct units, and an evaluation of those limitations, that takes you straight up to full marks. The leap from a low-mark answer to a flawless score isn't about being a physics genius, it's purely about strategy and presentation.
Finally, step 5, the unbreakable binge loop.
Okay, so you now have the ultimate framework for physical quantities and estimates, but honestly, the heist is only 20% complete. If you take the structured approach we just learned and just apply it blindly without understanding the specific instructions hidden within the exam itself, you are still going to fall right into the examiner's most dangerous traps. Because there are still massive, unresolved examiner traps waiting for you, you still need to conquer the absolutely hardest data analysis skills from past papers, and you desperately need a rock-solid revision map for the final 7 days before your exam. But the most immediate threat to your grade right now? Command word hidden traps. Think about it. Without mastering command words, even a top-band calculation method is just going to fail. If a question specifically asks you to explain a phenomenon and you only describe it, you get 0 marks for that section. None. It doesn't matter how beautiful or neat your working is. Command words dictate the entire mark band allocation, and they are absolutely the next crucial skill you have to master. And to make sure you don't miss the breakdown of those hidden traps, you really need to use all available resources. For example, subscribing to the Ace the Exams YouTube channel is an essential next step in your study session if you want to master these exact Cambridge techniques. So, I'm leaving you with a high-stakes question. When you sit down in that exam hall and the clock starts ticking, will you fall for the exact same command word trap, throwing away all those method marks you just learnt how to get? Or will you jump straight into our next explainer to speed run the command word framework? The heist continues right there. I'll see you in the next one.